Gold is an important metal. We adore it in jewellery, we value it as currency, we rely on it in modern electronics, and you can eat it, it even has an E number. But where does gold come from? Gold is found naturally in rocks and ores, but only in a few places around the world, in really low concentrations, alongside other metals. This is a problem. We use incredible amounts of energy and resources, including toxic chemicals like cyanide, mining and processing tons of rock to get just a few grams of gold out. This all has a severe and detrimental impact on the environment and our health. We need a better solution. From 1 ton of rock you can get up to a gram of gold, but you can get 300 grams of gold from 1 ton of mobile phones. It's therefore much more efficient and environmentally friendlier to recycle gold from waste electrical and electronic equipment called WEEE instead of mining it. Around 40 million tonnes of WEEE is sent to landfill every year. This is an urban gold mine. But WEEE has many metals in it and gold's not the most abundant one in there. How do I get gold out of your phone? This is where my research comes in. I investigate chemical methods for the recovery of metals without having to use toxic reagents. I use a process called solvent extraction, which has 2 liquids. We can dissolve all of the metals out of your phone and into an acidic water solution. This gives us a mixture of metals, including gold, which is the most valuable to recycle. The other liquid is an oil, which sits on top of the water and doesn't mix into it, much like oil sits on balsamic vinegar. I design molecules called extractants that transport the metal of choice out of the water and into the oil. If we can do this selectively, then we can separate gold from the mixture. This is a sort of molecular level gold panning. We're sifting through all the metals in the mixture and only collecting the one that we want. So how do we get selective gold separation? Every metal in the water has a certain size, likes to form certain shapes, has a certain charge, basically has a preferred chemistry. For example, gold likes to form flat squares. Platinum likes to form octahedra. I design molecules that can discriminate between the metals based on these features, bind to gold and only gold, and transport it into the oil. This selectivity is a bit like the child's toy where you can't get the round peg in the square hole. My molecules are particularly efficient. Not only do they recognise gold squares, they transport multiple at once as molecular golden nuggets. This gives us more metal out for less chemical used. We can then separate off the gold-containing oil and treat it to give us back the gold we treasure in an overall more efficient and less damaging process. At the start, I asked, where does gold come from? I'll repose the question, where should gold come from? The answer is we, because we are golden.